Let's dive deeper into the world of algebra, where equations with parentheses are like locked doors. We'll use a special tool called the distributive property to unlock them and reveal the hidden variables inside. Here is a tip. This mission will be a breeze if you've already mastered the basics. But if you need a refresher, take a moment to review the fundamentals, because having a strong foundation is key to success in any mission. Are you ready to crack the code? Great, let's get started. Welcome back. Today, we're diving into the exciting world of solving equations with distribution. By the end of this lesson, you'll be able to master the art of distribution. You'll confidently multiply the number outside parentheses by each term inside. Transform equations. You'll skillfully convert equations with parentheses into familiar two-step equations. Solve complex problems. You'll apply your newfound knowledge to solve equations that involve both distribution and basic operations. Let's get started. An equation with distribution involves parentheses. This requires you to multiply a number by each term inside the parentheses before solving. Basically, we are going to turn a complicated equation into an easy-to-solve two-step equation. In this example, we have 2 times the sum of x and 8. Solving this equation requires us to distribute the 2 before solving the equation. Remember that the number is understood to be 1 in a variable without a written coefficient. So, we are really multiplying 2 and 1, which will give us 2x. Next, a positive 2 times a positive 8 gives us a positive 16. We will rewrite this as 2 times x, or just 2x added to 16 is equal to 10. We will demonstrate these steps on the next slide. To solve an equation with distribution, we first distribute the multiplier. Remember, the multiplier is the number outside the parentheses. All the numbers inside the parentheses are multiplied by the multiplier. In this case, there are 2 terms: the variable x and the constant 8. Since 1 times 2 is 2, our first product will be 2x, which may be read as 2 times x. The second term will be 16, because 2 times 8 is 16. Now, we just rewrite the equation as a familiar two-step equation. We will solve this on the next slide. Let's build on what we learned in the last lesson to tackle this equation. Our first step is to isolate the variable term, 2x, by getting rid of the extra 16. Remember the golden rule of algebra: whatever you do to one side, you must do to the other. So, we'll subtract 16 from both sides. This leaves us with 2x on the left and minus 6 on the right. To find x, we'll divide both sides by 2. Since we are dividing a negative number by a positive value, the answer will be negative. Dividing negative 6 by 2 gives us minus 3. So, x equals negative 3. This problem might look familiar, but there's a twist. Notice anything different about the numbers compared to the last example? Take a moment to think about it. That's right. The multiplier and constant are both negative. Let's see how that changes things. Don't worry, math was the same. You'll still use break open parentheses and to a two-step equation. Let's get started. We are about to distribute a minus 2, so let's quickly review numbers. Multiplying 2 negatives or 2 positives gives a positive. Multiplying a positive and a negative gives a negative answer. Let's distribute. Remember, there's an imaginary 1 in front of the. So, minus 2 times 1x is negative 2x. Next, negative 2 times negative 8 is. Our equation now looks like this. 16 equals 10. Let's solve it on the next slide. To solve this problem, first, we will subtract 16 from both sides of this equation. This will give us negative 2x is equal to negative 6. Remembering that a negative divided by negative is a positive, we know that our final answer will be positive. We finish solving by dividing both sides by -2. Since -6 divided by -2 is 3, the solution is x equals 3. We are exploring equations that combine distribution and fractions. Don't worry about where the fractions appear, the usual math rules still apply. But first, let's review multiplying fractions and whole numbers. To multiply a fraction by a whole number, convert the whole number into a fraction by placing it over 1. For example, 5 will become 5 over 1. Multiply the fraction's numerators. Those are the top numbers. Next, multiply the fraction's denominator. Those are the bottom numbers. Finally, rewrite the fraction and simplify. We will see an example on the next slide. First, we will rewrite it as 2 over 3 and 9 over 1. This will help organize our work. Next, multiply the top numbers. In this case, it is 2 and 9. Then, multiply the bottom numbers. In this case, it is 3 and 1. Since 2 times 9 is 18 and 3 times 1 is 3, we have 18 over 3. Next, we will simplify this fraction. To simplify a fraction, divide the numerator, which is the top number, by the denominator or bottom number. For example, 18 divided by 3 equals 6. We'll see how this works in an equation on the next slide. Don't be fooled by the fraction. This problem works just like the ones before. First, distribute the number outside the parentheses to each term inside. Then, simplify the fractions and solve the two-step equation. It's really not that bad once you get the hang of it. First, we rewrote the problem by distributing 1/3 to the terms inside the parentheses, expressing all numbers as fractions. Next, we multiplied the numerators and denominators. Then, we simplified the fractions, transforming the problem into a basic two-step equation, which we'll solve on the next slide. To solve this problem, first, we will subtract 5 from both sides of the equation. This will give us 2 times x equals 4. Next, we divide both sides by 2. 2 divided by 2 equals 1. This leaves us with the variable x on the left side of the equation. 4 divided by 2 equals 2. So, our answer is 2. On the next slide, we will substitute 2 into the original equation to check our answer. We are going to check our work by replacing x with 2. I always like to start by rewriting my problem. So, now I have 1/3 of the sum of 6 times 2 added to 15 equals 9. Next, I multiply 6 by 2. I rewrite this as 1/3 times the sum of 12 and 15 equal to 9. Next, I add 12 and 15 to get 27. Since I am multiplying two fractions, I will rewrite 27 as the fraction 27 over 1. When I multiply 1 by 27, I get 27. This number goes in the numerator of a new fraction. Next, I will multiply 1 by 3 to get 3, which will be the denominator of the new fraction. Finally, I will divide 27 by 3, which is 9. Since 9 is equal to 9, this is a true statement. I know my previous work is correct. Now, I am ready for some independent practice. Organization is key to math success. Consider pausing this video and printing the lesson worksheet for better understanding. The practice problems are designed to be easy to focus on. I want you to concentrate on the essential steps to master algebra. Our example problem is 3 times the difference of x and 2 is 12. Step 1. Distribute the multiplier to the first term in parentheses. This is the first product. Step 2. Distribute the multiplier to the second term. This is the second product. The next slide will explain what we do with the first and second products. Also, pay attention to the warnings that remind you to watch your signs. We will use the first product and second product to write our two-step equation. The first term of 3x will go first, and the second term of -6 will go second. Both of these terms will be set equal to 12. The equation now reads 3 times x minus 6 is equal to 12. Finally, we'll solve the equation. The process is the same as before. Add 6 to both sides of the equation. Then, divide both sides by the number in front of x, which is 3. Our final answer will be x equals 6. The practice problems include equations with fractions, but they are solved using the same steps. Need help? Just ask. In closing, remember these 4 steps. First, distribute the multiplier. Second, simplify fractions if needed. Third, write a two-step equation. Finally, solve the two-step equation. Checking your work and substituting your answer back into the original equation is always a good idea. This verifies your solution and helps improve your math skills.